In this video, we will learn about the Flyweight design pattern and how to implement it using C++ code. Flyweight is a structural pattern that allows us to reuse existing objects so that we can ensure that our code is as memory efficient as possible. Let's learn how to implement the Flyweight pattern using C++ code. First, at the top of the program, we will include the map collection type. Next, we will create a string variable named red, set to the string red, a string variable named green set to the string green, and a string variable named blue set to the string blue. Then we will create a class named color. Let's create 3 subclasses of color, which will be red, green, and blue respectively. Next, we will create a class named color factory. Inside of here, we will have a map, which maps strings to color pointers. Our map will be named colors. Then we will utilize the public access modifier. We will create a function with an int return type named total objects created, inside of which we will return the size of the colors map. Then we will create a function that returns a color pointer named getColor that takes in one parameter, a string named colorName. Inside of this function, we will have a color pointer named color. Then we will check if the colors map already contains colorName, which we can do using an if statement and passing in colors.count colorName as the condition. If that is the case, we will set color equal to colors at colorName. Else we will check if colorName equals red. If so, we will set color equal to a new red object, and then set colors at key red equal to color. Else if colorName equals green, we will set color equal to a new green object, and then set colors at key green equal to color. Else if colorName equals blue, we will set color equal to a new blue object, and then set colors at key blue equal to color. At the bottom of the function, outside of the conditional statements, we will return color. Time to test our code. Let's go inside of C++'s main function. Inside of here, we will create a variable of type colorFactory named colorFactory. Then we will create a pointer to a color named color that we set to colorFactory.getColorRed. After that, we will set color equal to colorFactory.getColorGreen, then colorFactory.getColorBlue, and finally colorFactory.getColorRed. Notice that there are 4 calls to the colorFactory's getColor class, but there should only be 3 objects instantiated in the program, since the red object is referenced twice. If our Flyweight pattern works properly, the red object will be cached in the map and reused when it is requested the second time. To check this, we will create an int variable named number of objects that we set equal to a call to the colorFactory's total objects created function. Then we will output the string total objects created, and then the number of objects to the console. When we run the code, notice that 3 objects were created, meaning our code worked. Nice job. We use the Flyweight pattern when our program needs to support a large number of objects, which may not fit into the available RAM. The advantage is that we can save a lot of RAM if the program has many similar objects. Disadvantages of this design pattern are that some of the context data may need to be recalculated over and over each time a Flyweight method is called, leading to more CPU cycles. Also, this pattern makes the code a lot more complicated, in turn making it harder to read and maintain.